Hello viewers, welcome back to my channel. If you are new to this channel, I say a very big thank you for choosing to learn through us. This is a home where maths is made simple. So relax and see how simple we can make it for today's tutorial. Remember, in our last tutorial, we started with what limit is. We looked at the existence of limits, rules of limits, and also methods that can be used in evaluating limits. Now, in today's class, we are going to discuss one of those rules, one of the methods, which is use of direct plug, or what we call direct substitution. Now, let's see how to evaluate these questions. Remember, they are all simple. So relax and let's do it together. Okay? So we are going to have, for question number 1, we are all going to apply the rules of limits only on this question. Then, in other words, we go straight. Okay? So pay attention so that you see how to apply the rules of limits on limit problems. So we have question 1, we have solution. We have lim of x plus 4 as x approaches negative 2. So if we are applying the rules of limit on this will give us lim of x, split this limit on each of these terms as x is approaching negative 2 plus lim of 4 as x is approaching negative 2. When you do it this way, it means you are obeying the rules of limits. Okay? What we did was split the limit on each of these terms. Look at what we have. Then at this point, you do your direct plug. Okay? So we are going to have, remember our x is approaching negative 2. So we are going to have negative 2 to substitute with x. Then plus lim of a constant, as always, is always that constant. So we are going to have 4. I hope it's cleared. Replace your x with negative 2. Then lim of a constant is always a constant. So what we have is negative 2 plus 4, which will give us 2 as an answer. So lim of this is equal to 2. I hope it's cleared. Okay, let's look at the example 2. For this example 2, we are going to go straight without obeying the rule. So we have lim of 3x cubed plus 7x squared minus 2x minus 6 as x is approaching negative 3. So let's do our direct plug there. That will give us 3. Our x is 1 over 3. So we have 3 into 1 over 3 raised to power 3. I hope you see that. 3, our x is 1 over 3. Then we have raised to power of 3 plus 7 into our x is 1 over 3 raised to power of 2. Then minus 2 into our x is 1 over 3. Then negative 6. I hope it's cleared. 3, our x is 1 over 3 raised to the power of 3 plus 7, our x is 1 over 3 to the power of 2 minus 2, our x is 1 over 3, then minus 6. So what do we do next? We simplify. This will give us 3 into 1 raised to the power of 3 is 1 and 3 to the power of 3 is 27. So we have 1 plus 7, 1 to the power of 2 is 1, 3 to the power of 2 will give us 9. So we have negative 2 into 1 over 3 minus 6. So if we work it out there, we are going to have, that will give us, this is 3 over 1. 3 will cancel itself 1, cancel 27 to give us 9. So we're having 1 over 9 plus, this is 7 over 1. 7 we multiply 1, 7 over 9. So we have 7 over 9. This is 2 over 1. Negative 2 multiplies 1 is negative 2. 1 multiplies 3 is 3. Then we have negative 6. Okay? That will give us, make it over 1 so that we simplify. Then we take the LCM as 9. This will go through to give us 1 multiplies 1 is 1. This is 1 multiplies 7 is 7. 3 divides 9 is 3. Into this is negative 6. 9 multiplies this is 54. So we are going to have negative 52 when you simplify this, all over 9. Which when you simplify will give us negative 5 whole number 7 over 9 as an answer. Then number 3 we have lim of cos x plus 2 sin x all over 3 cos x as x approaches 0. So what we are going to do is direct plugging. We are going to have cos our x has become 0 plus 2 sin 0 all over 3 cos 0. Okay? Cos of 0 will give us 1 plus 2 into sin of 0 is 0 all over 3 cos of 0 is 1. So we are going to have 1 plus this multiplies this is 0 all over 3 multiplies 1 is 3. So this will give us 1 over 3 as an answer. Remember, if you have watched to this point, it shows what you are doing interests you. Please don't forget to subscribe to this channel and click on the notification button for more are coming. Now let's continue with example 4. So we're going to have lim of square root of negative x squared plus 20x minus 100 as x approaches 10. That will give us square root of negative 10 squared. Remember, negative x squared is not the same as this. These two are not the same. The square is only on this x. For this, the square is on both. So we are going to have this plus 20 into our x is 10, then minus 100. And in that case, square of 10 will give us negative 100. Plus, multiply these two, we have 200 minus 100. Then if you simplify this, it's going to give us 0. And the square root of 0 will give us 0 as an answer. Fifth question, we are told this is a function and it's given we have 3 functions here with their different intervals. For this first function, 4x minus 7, x is greater than 3. So if x is greater than 3 here, we are having numbers like 4, 5, and so on. For this function, the values of x are within negative 2 and 3. And for this last function, x is less than negative 2. So, but the question says, find the limit at x to be negative 1. So, which of these functions has x as negative 1? For the first function, it is not. Then for this, the values of x are between negative 2, negative 1, 0, 1, 2, 3. Then for this, we have x is less than negative 2. So we're going to have negative 3, negative 4, negative 5, and so on. So you see which of them has x as 1, negative 1, and that is this function. This is wrong. So for this, we are going to have the limit at x equal to negative 1 in this function. So that will give us x squared minus 3 at x approaches negative 1. So we directly plug in our x value here to give us minus x raised to power 2 minus 3. So we have negative 1 to the power of 2 will give us 1. Then we have minus 3. And 1 minus 3 is going to give us negative 2 as an answer. Please remember, if this video really answered a lot of questions for you, don't forget to give us your like, subscribe to our channel for more, and leave your comments with us in our comment section. Please follow Online Maths Useful and see you in my next class. Bye-bye.